Hey everyone, this is Miss Moriarty and I am here to discuss with us topic 6.3 as well as 6.4. In both of these topics, we're going to talk a little bit about the common fuel types as well as some of what their uses may be and how they are distributed around the world. So first, taking a look at what's known as subsistence fuel. Remember, that is a word where we've talked about it before, back when we were in Unit 5, where we talked about subsistence agriculture, right? That was where people were growing their own crops and harvesting their own crops. So same kind of concept applies to fuel. So a subsistence fuel is going to be one in which you can easily obtain. It's usually in your local area. So oftentimes that's going to be biomass. Well, what would be some examples of some common subsistence biomass fuels? That would be things such as wood or even charcoal. Right? It'd be very simple for somebody who maybe lives in a developing nation to have the tools to go out and cheaply obtain some wood nearby. Sometimes, in some cases, they can use charcoal. But remember, with using biomass, with using wood, although it is a renewable resource, you have to make sure that you use it wisely. So the more and more a country maybe obtains wood, the more deforestation or habitat loss we could potentially see. Now, an alternative subsistence fuel that we can also obtain that would be considered biomass is known as peat. So this is going to be partially decomposed organic matter. So this is usually vegetation, maybe like a fern of some sorts, typically found in a more wet, acidic-like area, like a bog or moor. We can use that peat, let it sit out for a period of time. We can dry it, burn it, and use it as a fuel source. The next piece is talking a little bit about coal. Coal is a very common fuel that, for the most part, majority of the world tends to use. It is a solid fuel type that tends to come from the remains of trees and ferns and plants that lived millions of years ago and have now, due to pressure and the overlying rock layers, have become solid. Now, looking at coal and how it potentially forms, there are actually different forms of our coal. So starting with peat, remember that's going to be our vegetation there. Over time, when those organisms die and continue to decompose and continue to pressurize, they become what's known as lignite. Followed by another set of hundreds of millions of years, they can become what's known as bituminous. And over time, eventually anthracite, which we see is farthest in the ground there. So it's got the deepest burial. Now, the deeper the coal may be, the higher the energy density it can provide. So anthracite, in looking at all of our different types of coal, is going to be the most valuable form of coal. When we obtain that coal as a fuel source, how do we use it to generate electricity? We tend to burn the coal, right? Combust the coal. Heat, usually a form of water, into steam. That steam turns a turbine, and that turbine powers a motor, which generates electricity. Now, a big takeaway here, guys, is that the more dense coal we have, so maybe the more anthracite we have, the more it'll burn for longer, much hotter, more steam, more electricity. How about petroleum? What is it and how is it formed? Petroleum or oil, these are usually underground deposits of hydrocarbons, water, and sulfur. So that's what you see here. Petroleum tends to migrate to the highest point in a formation of porous rock. And we tend to extract it by drilling down a well through the overlying rock or the impermeable layer of rock there, and then pumping liquid oil out under pressure. When we obtain that oil, it's usually in the form of what's known as crude oil. So this is going to be the liquid petroleum that is removed from the ground. Now, we can also obtain crude oil from other alternatives that are very, very similar. Those are known as tar sand. So this is a combination of clay, sand, water, and bitumen. Bitumen is actually a thick and sticky semi-solid form of petroleum, not necessarily a liquid. Extracting And using oil from tar sands, though, can be extremely energy and water intensive. It needs a lot of water to create the steam when it's then piped down to obtain the tar sands or bitumen, and lots more water tends to be used to then separate out all of the materials to then wind up obtaining the crude oil. Brings me to what is natural gas and how is it formed. So looking at natural gas, very similar to our other fossil fuels, right? This comes from the decaying of plants and animals, mainly found in more ocean type areas. Here we can see that natural gas actually tends to overlay, right, above the petroleum that has been formed in between the impermeable and permeable layers of rock. Now, the two largest uses of natural gas in the U.S. is usually for electricity generation or industrial processes. We should have seen in our electricity usage article analysis that a lot of states across the U.S. are now using more and more natural gas as a part of their electricity generation. When looking at natural gas, we tend to call it the cleanest burning fossil fuel since it tends to emit the least amount of pollutants and the least amount of CO2 when combusted. Right, and then last piece of our 6.3 here, what additional products could be made from our fossil fuels? So not only can petroleum or crude oil be used for gasoline in cars through a process called fractional distillation. We tend to burn the crude oil in a furnace. A vapor passes then into a column where the different hydrocarbons can be then sorted according to their boiling points. So we can obtain petroleum gas for our vehicles, right? We can obtain certain types of plastics, jet fuel, diesel fuel, even bitumen or asphalt for roads. All right, so that brings me to the practice FRQ for 6.3. For this, I recommend answering the question in the Edpuzzle as well as jotting it down somewhere in a blank space in your note packet, maybe on the back of the note packet. The first question is explain why a family living in a developing country would probably use wood to heat their home and cook their food. And 2, identify one environmental impact of using a subsistence fuel like wood. All right, if you want to check your answers, for the first one, explaining why a family living in a developing country would probably use wood. Right, a family in a developing country, remember we said is going to use more of a subsistence type fuel simply because it's easy for them to obtain and is relatively cheap. However, using wood can often lead to problems such as deforestation or habitat destruction. Moving on to 6.4. In the first slide of 6.4, we take a look at who has the greatest reserves of fossil fuels. Looking at coal, the United States or so kind of ranks number 1 here with about 150 years or so with reserves versus natural gas and petroleum have far less reserves in terms of the number of years that we have left. Now, how do we go about kind of estimating some of those things? Well, we can use what's known as the Hubert curve, which you see to the right. So this kind of tells us that the total reserves does not necessarily greatly influence the time it would take to use up all of that reserve. We can predict that things like oil extraction and the use would increase steadily until roughly half the supply had been used up, and that's going to be known as the peak oil use in this case. But since we continuously come up with more and more different types of technologies, we can say that we need to eventually, according to our curve, switch to other fuels long before our supplies become limited. Now, in continuing our discussion with the reserves of fossil fuels, right, why does it matter to know how much we have left? Well, we know that fossil fuels are a non-renewable resource, and so if we continue to use them at the rate in which we do, they will be depleted. Now, what can influence how much time we potentially have left? That could be through the discovery of any unharvested reserves. We could use more alternatives like tar or oil sands. We can take a look at Canada, who actually in the Alberta region tends to have more oil sand reserves. And so we can tend to use these to try and extend the time that we have between using up all of our petroleum or natural gas reserves in the end. So here, taking a look at our practice FRQ 6.4. So using the diagram here, identify the rock layer that must be porous and have enough permeability for fluid to move through the layer. So in taking a look at what our answer is here, the correct answer should technically be C, this layer here. So layer C is going to be the reservoir rock for both the oil and the gas. Here we know that our oil is going to wind up on top, our natural gas is going to wind up on top of our oil, and for it to wind up getting to that place, we can see that that layer of rock must be porous and sufficiently permeable to allow the flow of that fluid through the rock. Alright everyone, that is it for our video on 6.3 and 6.4. Please leave any questions that you may have at the end of the video.